This lesson is going to be over Unit 3, Pythagorean Theorem. Now, you'll need your 8th Math Notes packet. And the page I'm going to start off with is one that looks like this, Pythagorean Theorem Models. Now, Pythagorean Theorem has to do with right triangles and how the sides of that triangle relate to each other. And before we get into the actual official definition of Pythagorean Theorem, I want to go over some vocabulary or some terminology that's going to help you understand it a little bit more better. Now, the first thing we need to know is what a right triangle is. So a right triangle is a triangle with one right angle, exactly 90 degrees, and two acute angles. So on your 8th Math Notes packet, we're given this example here. And I'm just going to make this right triangle a little bit more prominent. And the deciding factor that tells us a right triangle is this little box that denotes 90 degrees. So that's a right triangle. Next terminology we need to go over are variables. So remember, variables are letters used to represent an unknown number. So a lot of times we use the variable x. In this case, we're going to use a, b, and c. We'll get more into that a little bit later. All right, we want to take a look at the area of a square. The area of a square is the length of one of the sides multiplied by itself. And that's what they have here in this example. So we take a look at one of the lengths. In this case, it's 1, 2, 3, 4, 5. Or we can just say 5 units. So we're going to take 5, the length of this side, and then we're going to square it, which equals 5 times, same as saying 5 times 5, and that equals 25. So we can say the area of this square is 25 units. And keep in mind, all 4 sides in a square have the same length. So that means this is 5, this is 5, this is 5, and this is 5. All right, next terminology we want to go over is squares and square roots. Now, a square is the result of multiplying a number by itself. And that's what we just did. We took this 5 right here, and we multiplied it by itself. We took 5 times 5 and got 25. So the square root of 5 is 25. The square root is the opposite of squaring. A square root of a number is a value that, when multiplied by itself, gives the number. So if we have, it's just going opposite now. So if we have 25, we would say that the root is 5. So typing that in on a calculator, it would look something like this. It would look like the radical symbol. We would say root 25 is equal to 5. All right. One thing I want you to also take note is the inverse of squaring is finding the square root. So just like in solving equations, so if we had something like 2x plus 5 is equal to, 8. Bring that down a little bit. So remember over here, it has the operation and the inverse operation. So remember that inverse operations is when you are moving items or moving terms, I should say, over to the other side of the equation. So we have our equal sign. We have a positive 5, and that operation's positive, so the inverse is negative. So remember, we would take the negative 5 and subtract on both sides. And it's the same thing with having 2x is equal to 4. Right here, we have a number being multiplied by a variable, so that's multiplication. The inverse operation of multiplication is division. So we would divide by 2 on both sides and get x is equal to 2. So now, what you need to know is the operation of squaring is taking of squaring a number is finding the root of that number. So just like the other example, if we had 5 squared, just like here in this operation, it equals 25. So the inverse operation would be taking that 25, putting the radical symbol, which means that we're finding the root of it, and that's equal to 5, because 5 times 5 is equal to 25. All right, some more terminology. I'm going to bring back this paper right here. Is the legs of a right triangle. So the legs of a right triangle, there's always going to be two of them, and it's where two lines meet at the 90-degree angle. So in this example, here's the 90-degree angle, and this line right here is adjacent, or what I mean, it's to the side, it meets it. So that means this side of the triangle is a leg, and this side of the triangle is a leg. So this is a leg and this is a leg because it is right next to the 90-degree angle. Also note that they're the two shortest sides of a right triangle, and they are represented as A and B variables. So that means this variable right here, or excuse me, this leg right here would be, we can call it A, and we can call this variable B. And also take note that it doesn't matter which order you put A and B. This could also be B, and this could also be A. All right, the hypotenuse. The hypotenuse is the longest side of a right triangle. It is opposite the right angle. So just like the legs are to the side of the 90-degree angle, the hypotenuse is actually on the opposite side. So that means you would find the right angle, draw an arrow to the opposite side, and that is what your hypotenuse would be. And the hypotenuse is represented as a C variable. So this would be the C variable. Let's see what else we got on here. All right, so now back to the definition of Pythagorean theorem. And the Pythagorean theorem is the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. So that means we're going to take these two variables right here, A and B, the two sides, we're going to square them, and we would get something like A squared plus B squared equals C squared. So the sum of these two sides, they're squares, which is why you see these squares, because it's squaring the sides, and that's what we're doing here too. And it's equal to the square, or the area, of this square right here. And keep in mind this can only be applied to right triangles. So the Pythagorean theorem, if you're presented with an A squared plus B squared equals C squared, you know you're dealing with the right triangle. And if you're presented with the right triangle, you would know that you're going to be dealing with A squared plus B squared equals C squared if you're ever trying to find any of the missing sides. Let's go to the next slide. So to kind of put that in action, I'm going to show you a quick little video. If you are more of a visual person or more of a hands-on person, I have two diagrams for you. So notice in this video, I'm just going to pause it real quickly. In this video, so this is our right, this is our right angle. So opposite of it is going to be our hypotenuse. And the two legs are going to be these two sides. And these squares right here, which are filled with water, are the two legs. So let's see what happens when she pours the water into the opposite end. So remember, this is A, this is B. Bam. It's exactly the same. She's going to pour it back. So that's just more proof that the two legs, which is A and B, equal the hypotenuse. And that can also be put into action. So here on the screen, we have delicious looking starburst. I'm going to move this up a little bit. I can't really go up anymore, but we can identify the triangle. So here's the right triangle. So we can say that the length of this triangle is 3 starbursts, 3 units, or 3 units. And if we square that, we would get 9, because 3 squared equals 9. Same thing over here. We have a length of 4 starbursts, 4 units. Square it, you get 16. So that means the square of this leg, A, the square of this leg, B. Remember, it doesn't matter which one you call A or B. The only one that does matter is C, because it's on the other side of the equation. So if we take these starbursts, and I'm just going to place them on top of the C, and we're going to take the B also. Oh, I dropped one. Bam, it matches up perfectly. So to answer this question right here, it says, from the video, what relationship did you notice between the square as the water was poured back and forth? What we noticed was that A and B equaled C. So as long as they're squared, this side and this side equals this side. We're not going to do that slide. So now, I'm going to move this out of the way. Let's take a look at this in action. All right, so this is an example we have, and we need to pay attention with what's given to us. So it looks like they give us a side length of A. So they call this one A. So that'd be one of the first step you want to do. You want to identify your A and B, and then identify your C, your hypotenuse. So this is going to be A. Let's see, this C. This is going to be C. And we know that because this is the right angle, and then opposite of it is always the hypotenuse. So that's going to be C. Tells us the sine length is 25. We don't know anything about B, so we'll have to find out something about B. Now, it's asking for the area of a square, 7. So 7 squared. It's the same as saying 7 squared, because the area of a square is taking one of the side lengths and squaring it. So that's going to equal 49. B, we don't know B, and we also don't know the area. However, we do know the hypotenuse, which is 25. So we can take 25 squared to get the area. And 25 squared is 625. And now we can set up our equation. Remember, Pythagorean theorem states that a squared plus b squared equals c squared. So we can we can write a squared plus b squared equals c squared. So whenever you're trying to solve these equations, that's the first thing you want to do. You want to write out your a squared plus b squared equals c squared. And then identify your two legs, the a and b, and then identify what your hypotenuse is. And then if you're given the area, you'll just fill in the area. Or if you're only given the sides, you'll have to find the area by squaring them. I'm going to go ahead and just fill in the sides. So A, we were given it 7. Add that squared. B, were we given B? We weren't given B. We were given nothing about B. So that's going to be our variable that we're looking for, b squared. Similar to saying x, we're looking for x, but now we're looking for b, is equal to c squared. So you can either go ahead and write 25 squared. You'll just have to write it out. Since I put 7 squared, I'm going to go ahead and put 25 squared. And then we're just going to get rid of those exponents, because 7 times 7 is 49, plus b squared is equal to 25 times 25, which we said is 625. All right, so now, just like we're solving equations, we have to isolate the variable. So as you can see, we have b on this side, but no variables on this side. Great, so that's what we want. We want the variable on one side, but we have constants on both sides. So we're going to need to move this 49, taking the inverse operation, which is negative. and subtract it on both sides. This cancels out because it's equal to 0. We get b squared is equal to whatever 625 minus 49 is. Now, if you have your Desmos calculator handy, we can go ahead and type in 625 minus 49. And we get 576. So we're going to write that in, 576. Okay, so now we're left with b squared equals 576. But that's not what we want. We want just b equals 576. So we don't stop here. We have a square. So we need to get rid of that square. So remember from one of the slides, yes, the inverse of squaring is finding the square root. So just like if we're taking the inverse of positive, it's negative, or taking the inverse of multiplication, it's division. Well, now there's a new one we're going to add on. So the inverse of squaring, so squaring a number, is finding the square root, which is taking that radical symbol. So what we're going to do is we're going to get rid of the square root. We're going to get rid of the square by taking the square root of both sides. So a square and a square root cancels out, and we're just left with b. B is equal, but now we have the radical symbol, so we're going to have to say b is equal to plus, whenever you do the radical on another side of the equation, you have to take positive or negative, but we're just going to say it's positive because, well, we're dealing with positive numbers if we're dealing with an actual physical side of a triangle. So b is equal to root 576. So that means we need to come here on the Desmos calculator. So your radical symbol is right here. We're going to clear this first. So we're going to say root or radical. We're going to type that in, 576. And what do we get? We get 24. So b is going to be equal to 24. Let me go back to this. So that's going to be your answer. B is equal to 24. So we're going to fill that in for 24. So we found the side. So the side is, so just like the side up here is 7, and the side for the hypotenuse is 25. So the side for the other leg is going to be 24. So 24 will go right here. So that's how you find missing sides with the Pythagorean theorem. Now, it is also asking for area of a square. So we're going to take 24 and square it, and that's going to be our area of this entire square over here. So 24 squared is, pull up Desmos, our handy dandy Desmos, and we get 24 squared, which is 576, which we said right here. Perfect. All right, so now let's move on to another one. Let's move on to models practice. Go ahead and minimize that. Okay. So if you're trying to find, so it looks like here, we're trying to find the areas. Most cases, you'll probably just try to, they'll have you just find the side length, but they're asking for the areas also. Now, the first thing we want to do is set up our equation. I'm going to write it up here. So our equation is a squared plus b squared equals c squared. And the second thing we want to do is identify which is which. So we need to identify our both legs, A and B, and then identify C, our hypotenuse. So our legs are going to be this 14, this 20. And again, remember the A and B, it doesn't matter which order you put it in. So we could call this one A and we can call this one B. It doesn't matter because since we're adding them together anyway, it doesn't matter which order we put it in. All right, and then we're looking for C. So we can go ahead and fill in our A squared plus B squared. Let me move down a little bit. So we can go ahead and fill that in. So A, we said was 14, so we can say 14. But don't forget the squared because that's part of the equation. So 14 squared plus B squared, which is 20. So 14 plus 20 squared is equal to C squared. All right, so now we need to get rid of these exponents. We need to go ahead and find out what they are, find out what these equal. So I'm going to pull up Desmos. Clear all. we're going to say 14 squared, which comes out to 196. So I want you to see me write that in, 196, plus 20 squared, which should be 400, but I'm going to type it in anyway. So that way you guys are comfortable with using the calculator. So we get 2, get that out of the way. So we get 2o squared, which is 400, is equal to c squared. So the way we're writing that out is 196 plus 400 equals c squared. So now we need to combine our like terms because this is a constant and this is a constant. So 400 plus 196 is 596 is equal to c squared. All right, that's not your answer. We don't stop there because we have this squared symbol. So we need to find, remember, the inverse operation of squaring is finding the roots, finding the square root. So we do that radical symbol on this side. If we do it on this side, we must do it on this side. So that cancels out. We're just left with c. So c is going to equal whatever root 596 is. So let's go back to our Desmos calculator, which I think that's what we had the last time, actually. So here's the root symbol, the radical. So radical 596. Nope, it was a little bit different. So we get 24.413. So we're going to say c is approximately, so writing right here, c is approximately 24.13. It was 24.13, right? Let me see. Oh, 24.41. 41. So C is approximately 24.41. So that means we can go ahead and fill in our chart. 24.41. And then, so now we need to find the areas of those. So what we're going to do is, all right, so this is going to be 14 squared. This is going to be 20 squared. And this is going to be 24.41 squared. All right, so what we want to do now is we're just going to type these into the calculator. So 14 squared. Let's pull up Desmos. Here, 14 squared, which is 196. So the area of the square for this square, for A, so 14 squared is 196. So the whole area is equal to 196. All right, 20 times 20, we already said is 400. And 24, let's go ahead, since we get a weird decimal number, let's go ahead and type that in on the calculator. So we get 24.41 squared is equal to 595.84 or 0.85. So it's very close to 596, which is 400 plus 196. So you notice the area of this square plus the area of this square equals the square of the hypotenuse. So we can put 596. And we just round it off since the equals the same. All right, let's take a look at the second one. All right, so this time it gives us the area of the square, and it wants us to find the side length. So remember, in order to do that, we just take the root. So the area, so because we want to know which number times itself equals 36, and that would be 6, because 6 times 6 equals 36. Now we have 81. So what number times itself equals 81? That's going to be 9, because 9 times 9 equals 81. So we can go ahead and fill in. So A, we have, this side is going to be 6. We have 9 for B, so we do 9. Now it wants us to find the length of C. We can do that with Pythagorean theorem. So I'm going to write kind of up right here for this one. So remember, our first step is to write out the equation and identify our A, B, and C. So we identified our A, B, and C, what numbers they are. So now we're going to write out A squared plus B squared equals C squared. Our A is 6, so we're going to say 6 squared plus B squared, which is 9, is equal to whatever C squared is. Now, they already did it for us right here, 36 plus 81, but I just wanted you to get in the habit of filling in your side lengths and then finding the area of that actual square. So 6 times 6 we said is 36 plus 9 times 9 squared, which is 81, is equal to C squared. So now we need to calculate 81 plus 36. Let's go to Desmos. 81 plus 36. We get 117. We go back to the, oops. So 117 is equal to C squared. All right, so now we have C squared is equal to 117. Let's go back to Desmos. 117. So now we need to find, oh, actually here. Okay, so C squared equals 117. So we have a square, so we need to find the root of both sides, and that'll cancel out the squared. So square root. That cancels out, and we're left with C equals whatever root 117 is. So let's go ahead and go back to Desmos now. Here's the root symbol, 117, and you should get 10, about roughly 10.82. So we're going to write that in. C is approximately 10.82. I'm just going to check my work. Yeah, 10.82. So we'll go ahead and write in the side length, which is 10.82. And the actual area, which would be this squared, or these two added together. So that's all we'd have to do. So you can either write it out completely, or you can just add these two together. So 81 plus 36, which was 117 we said. So this is the area, 117. So that's how you find missing sides. I'm going to do the last one here with you guys. All right, so we're given one side length and one area of the square. All right, so opposite of, so we have area 64, so we can find the root 64. So we can say root 64, which is, and just for practice, let me pull out the Desmos so that way you're comfortable with using it. So we can type in root 64 and we get 8. So this side length is going to be 8. We have 17, so now we're just going to square that opposite. So 17 squared, so 17 times 7. So we're going to say 17 squared is equal to, pull out Desmos, 17 squared, which is 289. Go back. Okay, so 289. So area is 64, area is 289. So now we need to find the side length of B. We can do that by either subtracting these, which is probably the easiest way, or finding A squared plus B squared equals C squared. I'm going to do A squared plus B squared equals C squared. So I'm going to say A squared plus B squared equals C squared. A, we said, is 8 or 64. So we can just go ahead and skip a step, write 64 plus, which is what we're looking for. B squared is what we're looking for. C squared, which we said is 289. All right, so now we need to solve for B. So take the inverse operation of positive 64, which is negative 64. We're going to be left with B squared is equal to whatever 289 minus 64 is. Let me pull out the Desmos. So 289 minus 64, which is 225. All right, so we have b squared equals 225. So we're going to take the root of both sides. That cancels out. We're just going to be left with b equals root 225. So typing that in on the calculator. Here's our root 225, and it equals 15. So that means b is equal to 15. That means that this side length right here is equal to 15. We can go ahead and fill that in. Let's type in on the Desmos 15 squared to get the area. We get 225, so we can fill in 225 right here. Now that's the same thing as saying, looking right here, 289 minus 64. So 289 minus 64. Let's type that in real quick. 289 minus 64 is 225, which is exactly what we got. So now you're going to work out. Oh, let's take a look at this one first. This missing side. Let me go over this real quickly for you so you can fill these in on your notes. All right, so it says the blank is always the blank side, and across from the blank is always labeled blank. So remember over here, we can go ahead and label our legs. Let's go ahead and do that. So this is a leg, and this is a leg. And we know that because A and B are legs. But if we didn't know what A and B were, we would know from this angle. So the legs are always adjacent to the 90-degree angle. And this is going to be the hypotenuse. I don't know if I'm spelling it right. And the hypotenuse, remember, is always the opposite of the 90-degree angle. So we can say the hypotenuse, the hypotenuse is always the opposite side and across from the 90-degree angle. It is always labeled C. All right, let's take a look at, so it says leg squared plus leg squared equals hypotenuse squared. So area of A squared, so that means it's the same equation that we were working with. So we can say A squared plus B squared is equal to C squared. All right, this says if the missing side is the hypotenuse, so if the missing side is the hypotenuse, remember our first step is to write down our equation, A squared plus B squared equals C squared. Identify your A, B, and C. So I'm going to say this one's A, this one's B. Again, doesn't matter which one. So we get 21. So we can say 21 squared plus B, which is 27 squared, is equal to C squared. So 21 squared, let's pull out our Desmos. So we get 21 squared, which is 441, plus 27 squared, which is 729, is equal to C squared. So 441 plus 729, and I'll let you guys see it in just a second. So 441 plus 729 equals 1170. Oops, I wrote that on the wrong spot. So 1170 is equal to c squared. All right, so this is the area. So now to find the actual side length, we would take the root of both sides. So 1170. 1170. Oh, actually, I have to type in the radical symbol first. So radical 1170. And we get 34.21. 34.21. So we can say the hypotenuse is roughly, oh geez, I already forgot the number. 34.21. 34.21. And they have inches. All right, we already did an example like this too, so I think y'all are good from there. All right, so that concludes the lesson on Pythagorean theorem.